Saxon Algebra 1 half, lesson 15, reading students. I hope you are having a great day because I'm here to make it even better with some amazing fractions to decimals. And back again, decimals into fractions. We're just gonna practice this, you guys. I know you've been working on fractions and decimals for a long time. It's one of those things though that is tricky, and for the vast majority of people, it takes a lot of repetition to really get this logged into your brain. So, bear with me. The first thing I want to tell you is that fractions and decimals are kind of like two foreign languages that are similar to each other. Let's call them French and Spanish. There's a lot of similarities between those two languages. A lot of the words are similar. They each have their own unique qualities, but if you know one, learning the other is a lot easier, and vice versa, right? It doesn't matter which one. That's how fractions and decimals are. Excuse me. They convey the same information in different formats, different styles, and once you learn one, it's a lot easier to understand the other, and then you can go back and forth. So think of them as languages we're translating. We're going to do a couple different kinds of fraction to decimal adjustments. I want to start with the easier kind first. So we're skipping ahead to example 2. We'll go back to example 1. You'll understand why. The instructions say to write each fraction as a decimal number. Okay, let's just remember what decimal numbers look like. That's where we worry about place value, right? And we know that these are the units or the ones place, the tens, the hundreds, the thousands, and up it goes, right? And with each place value, we add another 0. Well, decimals work kind of the same way, but here we're measuring numbers that are less than 1. So this is the tenths place, the 100ths place, the 1,000th place, the 10,000th place. We've talked about this, I know, I'm just reviewing it for you. So what we want to do is we want to take a fraction like a 3 over 10, and we want to convert it to decimals. Well, this one's really easy because the denominator of the fraction matches the name of the place, right? This is the tenths place, and this is 3/10. So we can really quickly get to 0.3 as another way to write 3/10, right? Because it just fits right in the blank. Okay, let's try another one that's also pretty easy. 2/5. Okay, well, there isn't a fifths place, but we can really quickly, and you don't even have to write it down, but in our heads, we can adjust this by multiplying. Let me just show it out. We're going to multiply it by 2 over 2 so that our denominator will be 10, and the new numerator will be 4. We have to adjust that as well. So now we can pretty easily see that's 4/10. Okay, when you get the hang of this, you don't need to show any of this. You can just go 2/5 equals 4/10 equals 0.4. Okay? One more. Oh, excuse me, I'm yawning. 3/20. Now, sometimes when students see this problem, they go, we have to make it smaller, but to make it a 10, we can divide it in half, but then it's 1.5, right? If we divide it top and bottom by 2, then it's 1.5, and how do we do that? Don't do it like that. Instead of making your number go down to 10, let's make it go up to 100. Now we have 15 over 100, and now we need to use the 100th place, but it becomes 0.15. Easy, right? So the moral of the story is that if the denominator of the fraction is a 10, 100, 1,000, if it's one of the names of the decimal places, it's really easy to fit it in. It's also fairly easy if the denominator can fit into one of these numbers really easily, okay? We can just adjust the fraction and get it to match, and then we're good to go. So that is this example. And by the way, John usually writes a lead 0 before the decimal. That's not important to me. If you like to put that in, that's fine. These are the right answers. If you like to put 0.3, 0.4, 0.15, that's fine. If you just write 0.3, that's fine too. I think adding the 0 is a little bit clearer because sometimes our decimal places are little and they can get lost in the sea of handwriting. So if you want to be sure that the person knows that you've got a decimal place there, you can put the lead 0 so it's obvious. Or you can just make really nice firm decimal points and then you don't have to worry about it. Remember that we never say 0.15. This number is not 15 because this is not in the tens place and this is not in the ones place. We can say 0.15, but we can't say 0.15. So don't say it. All right, let's go back and do the first kind now that are, I think, harder, definitely messier. We've only got 2 to do for this one. 3/8. There's no easy way to put 8 into 10, 100, 1,000, etc. It's not like 5 or 20 that we can easily adjust. It's not going to go in there without a fight. So we have a different strategy we use. We remember that this line always says divided by. So we can turn this into a division problem and that will generate for us the decimal number. So we do 3 divided by 8. Remember that looks like this. The top number goes inside the box. The bottom number goes on the outside. And we look for decimals. There's nothing in here. 8, there isn't a decimal out here anywhere. There isn't a decimal existing in this number that we have to take into consideration. 8 into 3, it doesn't go. So now we need to bring down a 0. So what we do is we add the decimal here, we add it there, then we can put a 0 in, okay? 8 into 30, well, 8 times 4 is 32. So that's too big. 8 times 3 is 24. So that's our best bet. 8 times 3. 3 times 8 is indeed 24. We subtract, we get 6. We can bring down another 0. Once our decimal's in there, we're locked in, we're anchored, we're good to go. 8 into 60. 8 times 7 is 56. I think 8 times 7 being 56, I think that's the most difficult multiplication fact to remember. When my daughters were young and were learning their multiplication tables, I don't know what that was, 3rd grade or something for the oldest one, she got, the American Girl dolls? She got Molly McIntyre, which is the historical girl from World War II. And one of the really cool things that came with that doll were little classroom material. She had a little notebook, a little pencil, a little book bag, all those cute little things. And there were also, it was supposed to be like a little deck of flashcards, multiplication fact flashcards. I'm sure you've seen these. They're old school, but they look like this. And it said 8 times 7. And there was only one actual card, and that's the math fact that it was. So we always called 8 times 7 the Molly McIntyre fact. So there you have it. It's Molly McIntyre's fact. 8 times 7 is 56. We subtract, we get 40. Aha! 8 goes into 40 evenly. It goes in exactly 5 times. So our answer is 0.375. Not 0.375, 0.375. Again, leave 0 if you want it. I don't usually put them, so I'm not going to. But again, if you like it, you can. All right, so that's how we handle decimals where the denominator does not fit into our place value fractions easily. One more. That one that we just did, that worked out nicely, didn't it? We needed to go to 3 digits, but it worked out fine. We got a nice clean answer after 3 decimal places. And now, we'll do one that's gross. 1 divided by 30. Okay, This is to remind you that we don't have an easy way to do it, so we have to make it say divided by, and it's 1 divided by 30. Does 30 go into 1? Not really. So we'll have to add the decimal. 30 into 10, no. 30 into 100, yes, 3 times. We need to put the 3 here so that when we multiply, everything will line up right. But there's a blank space there, so we need to fill that in with an extra 0. My zeros suddenly look really weird. I guess I'm making them differently. Okay, now we subtract, we get 10. Uh-oh. We bring down a 0, it's 100. It's 3 again. It's 90 again. We subtract, we get 10 again. Uh-oh. We bring down, it's 3, it's 90, it's 3, it's 90. It's the same thing over and over again. So we can put that bar there to say it repeats. So we can write it like this. This is perfectly fine. Or we can round it to the nearest 100ths place. We want to round to this digit. This one tells us what to do. 3 says stay. So we put 0.03, and then we put that line over the top that says it's repeating. So that's the best way to show a decimal number that does not resolve itself. Okay, we just talked about that. We round repeaters. Remember that when you're rounding, whoever's calling the shots on your problem, John in this case, he has to tell you how many digits to round to. That always confused me. I thought, is there some like way to decide how many digits you should round to, or is there some kind of rule? No, it's just whatever you want. So when you're doing these problems, John needs to tell you what place to round to or how many digits should be in your final answer. Okay, here's the problem. Round 42.617 to the nearest millionth. Okay, well, what this part means, remember, it means the part that repeats is what's directly under the bar. So here I wrote it so it was only over the 3, right? Because just the 3, not the 0 that repeats. Here, it's the whole 617. When I start talking for math, you guys, I just start yawning. It's so weird. Okay, so what I'm going to do, I can't remember right off the top of my head how many decimals are in a millionth place. So I'm going to write this out, and then I'll figure that out. I'm going to write 617. I'll write it 4 times. I'm sure that covers millionth, right? So I take that pattern, I repeat it. Oh, look, I wrote it wrong. Because I said I was going to do it 4 times, so I wrote a 4. Tricky. Now I'm going to count out the places. Ready? Tenths, hundredths, thousand, 10,000th, 100,000th, millionths. So we're supposed to round it to the nearest millionth. And so that's the digit. It's either going to stay 7 or go up to 8. This is the digit that tells me what to do. Remember, 0 through 4 is stay. 5 through 9 is go up. This is a 6, so my final answer is 42.617618. All the rest drops away, and that's my final answer. This was right too. 42.617618. Beautiful. Okay, that's our work on taking fractions into decimals and then rounding decimals to reasonable lengths. Again, John was the one who decided. We don't call the shots on that. And we'll talk more about this as you work more advanced problems. Generally, what I like to see is I like to see you round to 2 decimal places. That's kind of our rule of thumb for high school algebra, which we're still warming up to. So this isn't always true, but generally that will be our rule. Okay, decimals to fractions. It's so easy. It's so much easier, you guys. 15.4. Write this number as a fraction, 0.041. All you have to do is remember the names of the places. That's 1/10th, 100th, 1,000th, right? So this is the place value of the smallest digit. So that is the denominator. And the numerator is whatever's in the decimal places. Cute, right? That's easy. We reduce if we can. 41 is prime, so that is not going anywhere. All right, and here's the last problem of the lesson. Write 0.35 as a fraction. Again, we go, okay, 1/10, 1/100th. Okay, so it's going to be 35 over 100. But that can be reduced, can't it? Because 5 will fit into both of these. So let's divide top and bottom by 5. Right now, that's our best guess at the greatest common factor. We're not going to take the time to figure it out, but we're just going to use our best instincts. We just look at the two numbers and consider it. You know, will 2 go in? Will 10 go in? Will 5 go in? Will 3 go in? And as we keep doing math, we'll get better and better at finding those bigger numbers. But we'll start with 5 and see where we get. 35 divided by 5 is 7. 100 divided by 5 is 20. And once you see a prime number in either the top or the bottom, you know you're done, because prime numbers cannot be divided by anything but 1 in themselves. So our final answer is 7 over 20. Satisfying? I hope so. It's so much easier to go from decimals to fractions. The pain is when you have fractions to decimals with repeating digits. It's kind of satisfying, I think, when you see something that looks ugly, but then it ends up coming out evenly. This one, we definitely would want you to take it all the way out. And remember, that didn't make sense, don't worry. Remember that when we want our answer to have decimal places, that means we actually have to find 3 decimal places, and then we round to 2, right? Because you have to have that third digit. Here it is. You have to have that extra digit, right? Here we were rounding to the nearest millionth. You need one more digit to tell you which way to handle your rounding. So when I say that your answers in algebra will have 2 decimal places, that means you'll have to work them to find 3, and then you'll use rounding. Okay, I think that's enough talking for now, right, Nat? Don't you? Our next lesson will be lesson 16. I will see you there. I will also see you for a check-in, a video chat check-in on Friday between noon and 3 p.m. or by appointment on Thursday. Alexis, you have a standing appointment, so you don't have to worry about it. But everybody else, I'll see you on Friday, or else reach out to me, okay? Oh, wait, let's see. I'm talking to Joel as well. Joel, you have a standing appointment too. Yours is at noon. So I guess the person I'm talking to is JoJo, and I've always talked to you around the same time as Friday. So we have a date. You guys are all set. Oh my gosh, you're so good. That's all. Goodbye.